Okay, so let's start. I'm really looking forward to this talk. Why that? Because I do a lot of clouds in the last 2 years, and I would like to explain you how it happened and what actually happens in my projects. So let's start with the show. And thank you for the invitation. So what I see is companies come to me and say, okay, help us to go to the clouds. And I say, why? It's like, yeah, because it's our strategy. So, okay, fine. So why is the strategy? Nobody knows, right? So it's usually the larger the company, the less obvious it becomes. And then and the assumption is, it's going to be easier, cheaper, and so forth. So there's almost nothing to do. Just pick the application, put it in the cloud, and you are ready. And what I would like to cover today, the different choices we have with the clouds and what you can do about that. So let's start with my introduction. So I'm a Java developer. I'm backend. Whatever I'm doing is actually Java, nothing else. And in the front end, I do also web components with plain vanilla JavaScript, so no framework so far. Works nice. So this is what I'm doing as a developer. And I'm working as consulting, performing code reviews, and helping companies with proof of concept migrations and firefighting or whatever. So it never gets boring. Okay, so now if you like, there is a podcast. So I'm publishing usually a weekly episode with various guests from the software industry, usually Java related. And AHEX Live. This is a conference workshop around the corner, if you like. So it is going to be a relevant or similar or related to the topic we talk today. Okay, and if there are any questions left, feel free to publish the questions to the AHEX TV. You don't have to register, just GitHub gist or ask via Twitter during the show or chat, and I try to answer all the questions once a month, but I won't answer any technical questions via email. So that's the deal. Okay, talking about architectures. So I actually added the slides shortly before the show because the last 3 points are significant, so I split them. So what you could do, this is what we always did, monolith. So I always did monolith. They were, for unknown reasons, out of fashion because there were lots of microservices. That was very fashionable. So I remember a Java user group meeting where a small team of 2 developers managed to deploy 100 microservices, and then they asked me, what is the best way to start them? So again, I have no idea. This was before Kubernetes. And I asked them, why are you building so many? So yeah, because we have to do microservices nowadays, right? This is microservice architecture, something good. And Netflix is actually doing microservice as well. So I stick with monoliths, and monoliths, what I'm usually doing is a view, I would say, I don't know, larger. I mean, from the business perspective, maybe larger, but not, from the size perspective, maybe smaller applications, reasonable 5 to 10 applications. Let's call it microservices or not, and they sometimes communicate with each other or not. So monolith, from my perspective, is a best practice. If you can ship a monolith, you are done. All the problems with CAP theorem and so forth do not apply. Of course, you cannot do this always. So in my current project, this is a product and they would like to ship modules, different modules. So it is, you could do this actually with monolith. We did it also in the past. What you will have to do then, introducing kind of licensing model or deactivating modules, which is also an option. But they decided, to ship a few microservices, and the client gets what the client expects. So what microservices are? Microservices are, how are they defined? So microservices is a process which exposes HTTP and JSON, and they communicate with each other through public APIs. This is a microservice. So I would say a small app or a small service with a REST interface, I would say, is a microservice. And then functions like AWS Lambda, for instance. And it's not obvious, but there are 2 kinds of functions. There are asynchronous functions and synchronous functions, and they behave differently from the error perspective and how you call them. And we will cover them both. And synchronous functions usually are functions which listen to HTTP. I would say the vast majority of such functions are listening to HTTP events. They look like microprofile REST applications, something like this. And event-driven architectures or asynchronous functions are functions which listen to Kafka-similar streams or topics. And in the cloud, it would be SNS, SQS, S3, Kinesis is a classic one. Kafka, of course, you can use Kafka, but there is no one who waits, for the response. It's just, events happen in the business, and you are just reacting to the events. And I was almost done with the slide, and then I got say, wait a minute, there's also an option no code, and I'm not meaning that you can actually write, not like a drag and drop and stuff like that, but what you could actually do is you could, for instance, configure S3 buckets. So if someone submits a file to S3, event is going to be is going to happen, and with minimal code or low code, you could actually you can automatically push the event to Kinesis, do something with it, or make an asynchronous Lambda wake up and do something with that. Or like, lifecycle methods, or how it is called, lifecycle on S3. So you can say, if the file is older than 2 days, put it automatically to the next layer. So, or to the next, how to call it, to the glacier, to the next latency class, I would say, and make it cheaper, of course. That's the deal. So and I would say no code is great for small things, because I don't have to implement a polling mechanism to see whether something arrived in the folder. I could just use the cloud for that, for instance, right? So I'm listening to the events. Okay, now expectations, and this is actually in all my projects so far in the last 2 years. So the expectations, Jakarta E or microprofile, whatever you did, this was or is my world still. It's okay. This is lots of plumbing, heavyweight servers, and clouds are nimble and fast and easy. So no plumbing, no code, low code. And then single click deployments, like you go to the console, click on the button, and it works. Oh, by the way. I was in a project, in a Java project, and I had a discussion, and a script developer came to me and say, okay, Java is not, capable of to being a good Lambda function. Say, why not? It's like, yeah, because we can directly copy, our script code to the AWS console as a Lambda, and it works. I say, yeah, but let's imagine you have 100 such functions. You have no idea what you copied, which version it is, and how you move it out. So yeah, they can use Cloud9 to access the function. Everything is right. But I would say what I'm thinking, even in the cloud, we need something like Maven, which builds the entire thing, versions the things, and ships it to the cloud. It's not like we just do some stuff in the console and hope that in a few years the console won't change from the UI perspective. I will exactly remember what we actually did, right? So I would say, and I'm speaking here about more serious projects where you will have to ship multiple something to the cloud. Then endless scalability. Also, the cloud scale is endlessly. The first you will hit your account limit, but let's say you will have to think about scalability as well. This is not endlessly. At least there are various APIs, and every API is different with different limits. So you have to think about this. It's not that different to thinking about application servers. By the way, if you know application servers, you will find yourself understanding the cloud better, because it's very similar concepts. So agility, speed, and ease of use. So the ease of use, it depends. So what I found out is actually the Java code we write is perfectly simple, portable, and as simple as it was before. But what we have to write in addition to that, tons of infrastructure as code, YAMLs, JSONs, or Terraform scripts. And and this is, I wouldn't say it is complex, but you have to spend a lot of time, and also debugging issues like, forgotten ports, or to open a port, security groups, or of course the classic, as forgot about the permissions. Then pay as you go is a myth, I would say, because this is the ideal, right? But what happens is, after the system is running in production for months or two, your manager gets an email. If you buy, reserved instances in 3 years or 1 year in advance, you get, 70% off. And I mean, saying more than 50% of all cases, not non-serverless low workloads are running actually as reserved instances, which is way cheaper. But this is definitely not pay as you go, or this is just a partially pay as you go. So low cost, this is definitely not true. So put it this way, I would say a Raspberry Pi on your desk is orders of magnitude cheaper, more cheaper than a comparable CPU in the cloud. So this is a truth. And even an EC2, as small as EC2 in the cloud, is going to be more expensive than a smaller machine in your data center. Okay, so then we have low costs. Yeah, we had it. And microservices on Kubernetes is the end game. So this happens all the time. So the assumption is we have Kubernetes on premise. Let's now put everything onto Kubernetes on public cloud and it will work. So this works the best, I would say, with GCP, Google Cloud P. What is platform? Maybe Google Cloud works the best Kubernetes because they have a nice Kubernetes support. In the other Azure or AWS, they also have Kubernetes support, but Kubernetes came after the clouds already orchestrated Dockers. Or the question is, why we need Kubernetes in the cloud, right? This is the first question. And Kubernetes in the cloud. So why we need Kubernetes at all is we need something which starts and stops the containers and gives, allows the containers to be via IP address, DNS name, or whatever, and we don't like to have port collision. So if this is, and health checks, of course, right? So if the port doesn't answer, we will kill the port and restart the port. So that's the basic idea, or the killer use case of Kubernetes. So now, all the clouds I know, they have, other possibilities or other solutions to the same problem. So Azure Container Instances or Azure App Service on AWS, the classic would be ECS Fargate, which is even serverless. So the configuration is way simpler than Kubernetes, and this service is cheaper. So to the cost will come a little bit later, but the service is cheaper. So what it means is, actually, the most important thing is, your workload, your business logic is portable, which is. I mean, we are Java developers, it works. And then the amount of configuration should be minimal. So interestingly, if you pick Kubernetes and you will generate something with Helm charts or something similar, you will find yourself, you have write out lots of YAML. And for instance, if you ship your Kubernetes app to AKS on AWS, you will find yourself configure something twice. For instance, security. The Kubernetes has its own users, and the AWS has own IAM users, and you will have to sync them or have to integrate them, which is not trivial. So what I think is Kubernetes is the killer use case for private clouds. So if you run your own workloads with more than 2 or 4, let's say, Docker containers, because 4 Docker containers would mean actually 8. Kubernetes would be maybe the simplest possible solution. And in the public clouds, there are different solutions to Kubernetes, which are way simpler and cheaper. What you have to know is, usually, if you set up Kubernetes cluster, you will have to pay for the so-called control plane. But it is like roughly €100 per cluster per month. And this is really depends on but do the math, it depends on the region and so forth. But this is our rough numbers. And if you do the same with ECS Fargate or Azure Container Instances, you won't pay anything, pay anything, right? It comes for free. Okay, so now the lift and shift or rehost, this is what I get questions a lot. We do this, and I'm a bit against that, because if you are going to the cloud right now, the management actually expects an improvement, and the rehost is something like refactoring what you did before, right? So it's like, let's improve the application and hope that after that it behaves exactly like before. Maybe the internal logic is a little bit improved, but the user doesn't see any difference. And with the rehost, what usually happens, the costs are higher usually. So do the math, but usually they are. Maybe you can scale better. No, maybe usually you can scale better. You can put more resources, but it's more expensive. And from my perspective, if you can go to the cloud, but use the cloud better than just use cloud as a better virtual machine. Okay, now Kubernetes. So what Kubernetes is, and this is maybe why it is more expensive than the others, because it comes with control plane. You will need a couple of etcd machines. You will need the kube API server, kube schedulers, and you will need also the worker nodes, the kube proxies here, so-called kubelets. So, and they will run on the clouds on the standard EC2 machines or virtual machines on Azure, and you will have to pay for the machines. So now, and even Kelsey Hightower from Google said, Kubernetes, a platform for building platforms, is a better place to start, not the end game. And what it means is, if Amazon or Azure or Google are using Kubernetes, to start and stop container instances, I don't care. But I don't like to fiddle, with lots of YAML. That's the truth. And for instance, if you go to AWS cloud, for instance, you get the application load balancer. You don't need, the ingress controller from Kubernetes. So what I wanted to say is that public clouds are different than private clouds. So there's a difference between both environments, and you can do easier, better, and cheaper in public cloud than just taking your Kubernetes from your home deployment and pushing it to the cloud. Okay, so now in public clouds, so let's take a look at compute on EC2. Which possibilities do we have? And EC2 and ELB, is this what happens first? This is the first services Amazon launched in 2006, and Amazon was the first. There were no other cloud providers back then. And what EC2 is like a server, but runs in the cloud. And by the way, funny fact, at the beginnings, Amazon supported SOAP exclusively. And after a few years, I think it was roughly 2010 or something like this, no one wanted to use SOAP anymore, and they switched to REST. And back then, what I had to do is I had to generate the Java classes from the WSDL to access Amazon to play with it. So, but EC2 and ELB, it came first, and this is the basic infrastructure. So what it means is actually from cost perspective, from cost perspective, if you would launch an EC2 instance in Amazon, it is going to be the cheapest possible solution, because it is the bare metal machine. And from the overall perspective, it may be the most expensive solution you can properly deploy. Why? Because you will have to patch and to care about the machine as you do in your data center. So there's not a lot of difference, except the IP address is different. But EC2 is the cheapest possible option. And if you will buy the machines in advance, 1 or 3 years, or run on spots, I wanted to say hotspots, on spots, then it's even cheaper. So, and the ELB was the elastic load balancer, which was replaced on application load balancer. With ELB and EC2, you could actually run your own cluster. So this was the beginning of cloud applications. So now ECS, more interesting, is also old. So I just looked at the my YouTube channel, and the first ECS screencasts I created were a few years ago. So it's actually pretty old. And ECR is this Elastic Container Registry. And this ECS Classic, I would say, works that way that you are provisioning the EC2 machines. So you have to pick your EC2 machines, and what Amazon does or AWS does, it install on these machines the Docker engine, or whatever you call it, the Docker environment. So why I'm telling you this? Because it's obvious that ECS has to be more expensive than EC2. So if you would run EC2 instead of EC2, ECS instead of EC2, the entire month, you will spend more money than just running EC2. And but you don't have to care about the operating system. So that's the idea. So I don't have to patch the operating system. I'm completely abstracted from the machines. And one step further is ECS Fargate. So this is even better. And I like Fargate a lot. So what Fargate is just like ECS, but you don't use the machines anymore. You just say, I have a microservice, or I have a Docker task, or I have a task. This is the official name, the task. And I say, you task, you get 2 CPUs and 500 RAM gigabyte of RAM, and this is all I have to do. And and what ECS Fargate will do, it will start new tasks on demand, so I can specify manually or with auto scaling, and it will scale out and scale in on demand. And of course, Fargate is more expensive than EC2, but it doesn't have to be more expensive than plain ECS. So AKS is Kubernetes, which also has to run on ECS, on EC2 on the machines, and the EKS or Kubernetes here. The Kubernetes is similar to Fargate, except it's a standard open source, but it needs more ECS EC2 machines to run. So therefore, I think it is this is why you have to pay for the control plane all the time. So now AWS Lambda. This interesting one. It is actually similar to Fargate because you can run also Fargate like in a schedule. Like you can run in Fargate in a mode where you have a task which is which wakes up and moves away, or you can run Fargate in continuous mode. And Lambda is like request scoped in microprofile. And what interesting is ECS Fargate, EKS is also available as Fargate, and Lambda are serverless solutions. So this is the name for it, serverless. So what it means is serverless means I don't care about the servers. I don't see the machines anymore. I don't have to care which operating system runs. I don't care about the patching. So AWS just takes more responsibility, and you focus more on business logic. This was actually the entire idea of application servers 20 years ago, but now we are almost there. So now the Amazon Lightsail and UpRunner is like ECS Fargate with different business model. So with Lightsail, you get fixed costs. So you can say I run the. By the way, if I say run, you can run Java apps. So I'm talking about Java applications here. So with Lightsail, you can run, and with UpRunner, you can run their code all the time for minimal cost. So Lightsail is minimal cost, and AWS UpRunner is like the simpler alternative to ECS. So UpRunner is simple alternative, and Lightsail is like a lightweight way to running containers. But Lightsail is going to be as almost or a little bit more expensive than EC2. So it is very similar pricing model. And Outposts is something interesting because with Outposts you can buy hardware from AWS, or Azure Stack is the Azure name for that, and product, and AWS Outposts. So you can buy from one unit, so it's like one pizza box to several, and put it to your data center, and they will run as. Then it will be almost like a private cloud, but it will be still managed by AWS. So AWS will manage the servers, but the data will remain in your rack. So these are the possibilities. So now, to understand it, storage. So storage is interesting because what the compute, everything here is stateless. And with the storage, this is where it becomes more interesting. And so S3 is the cheapest possible storage you can probably get. So it is. It looks like a Java hash map, I would say. It's this object storage. It means the value gets replaced on every call. Then the instant storage, what it means is, instant storage means if I'm running on ECS Fargate, let's say, every node gets instant storage like a Docker layer. That's exactly the same concept. And the instances can store data there very fast, but it's ephemeral. It means if I destroy the instance, it just goes away. And EFS is like NFS, but with elastic file system, not a network file system, but it's exactly the same technology, but from Amazon. I would say this is not that, cloud native, but is nice to have. And by the way, even AWS Lambdas support EFS. And now it comes RDS. This is more interesting because RDS, you can run Postgres on RDS. And Redshift is like the data warehouse version of Postgres. And RDS, relational database service, or data service. I think database service. And there's a Postgres, MySQL, MSQL, and Oracle. You can run RDS, and most, actually, all my projects we use Postgres so far. And then Aurora, and there is a Aurora RDS Postgres, which means this is like re-implemented Postgres, which runs in serverless mode on AWS. So and this is like the same spectrum. So what it means is S3 is the cheapest. And whether RDS on Aurora, the cost, this really depends because, of course, if it's RDS, it runs on EC2, so you can buy the instance in advance. And Aurora is very dynamic, so I can scale in minutes shut down the database and scale up the database. So, by the way, I mentioned several times serverless. So who cares, right? And by the way, the name is completely wrong because you always need servers. So from developer or technical perspective, forget it. But it is the business case. You are not buying servers. You are paying for per invocation. So this is for me the difference. And serverless would also mean for me is if I say I have a ECS Fargate cluster and I scale everything down, I wouldn't like to pay anything. Then it's serverless. So then interesting question right now, is Kubernetes serverless? Because if I scale everything down, I still have to pay for the control plane, but it really doesn't matter because you pay 100 euros per month. It's not that big deal, but still interesting question, right? Okay, so now Aurora is serverless. You can run it in several modes. So, and Aurora would be like the most interesting. Or if you're running Postgres, take a look at Aurora. It comes with master replication. But then DynamoDB, Athena, and Neptune. So DynamoDB is really interesting. It's like Cassandra. Actually, DynamoDB was a paper, and Cassandra is very similar to that. So read the paper and implemented the open source version of it. And lots of NoSQL databases are based on DynamoDB idea. And DynamoDB, I would say this is the best possible developer experience if you would like to use a NoSQL database, because there's nothing to install. So if you would like to have RDS or Aurora, you will have to wait 5 minutes until something happens. And DynamoDB, you just say, give me a table, and you have the table, and you get a call per second. You get paid per call. This is what and per second, of course, because it's there, but more or less per reads and writes. Okay, they are differently expensive. It's also the different costs, whether you would like to have consistent or eventual consistent writes. Okay, now, are clouds killing microservices? This is the next question. Now you got to know the overview of AWS cloud and Azure. So AWS was first. This is why I'm going with AWS, and the other clouds are similar. So what they do over the time there, they provide similar services. So are clouds killing microservices? This is interesting part, because if you so why I got the slide, because in all projects so far, if the manager sees at the end of the month, the first bill, and sees like 5 processes and they cost that much, the first question is, why are we not merging them into one process? Then it becomes cheaper. And I get the questions all the time. So these are actually valid questions. So I actually asked the question before public clouds, if we had an application server with one war, and inside the war were like 50 jars. I always ask the question, why are you doing this? Why are you just not putting everything to one war? It's just easier. And we get the question, now it becomes transparent in the cloud that every microservice incurs costs. So every microservice is a process, so it will cost you some money, and every process comes with an overhead, of course, because as even Lambda comes with overheads. The entire environment has to be initialized, and you are paying for the overhead as well. And so if you would ship one monolith, it is going to be cheaper to run than 10 microservices. So of course you can argue, but we have more benefits with the microservices. But you will have to explain it the first time directly to your manager what the benefits are. So now I would say the discussion shifted between architect to developer, because now every developer is an architect. You can basically do whatever you like, more or less, in the cloud. So you will have you are accountable now for the costs. So you have to go to the manager and explain why you're shipping 100 microservices at once, and there is no way in the process to just replace one microservice, which you sometimes see in real world. Okay, so now there will be lots of talking. So this session is exceptionally slide full. I would say not slideless, but yeah, once a while is okay, I think. Now, this is what I meant. Monthly cost-driven development. Recently, I saw a blog post somewhere where someone said, "Okay, I find a way to minimize the cost to S3 to make everything cheaper." And of course, from the software engineering perspective, it looked terrible, but the costs were minimized. So what I expect to see in the upcoming years, that we will see really crappy code, or code which is suboptimal and hard to understand just to minimize the costs. So this is my expectation for the upcoming years. And then what will happen, the first project are not going to be, or, the project are not going to be very successful because the maintenance will kill us. And then we say, okay, who cares about the monthly costs? The maintainability is the most important factor, which is reasonable. So minimize the amount of API calls, use the least amount of virtual CPU possible and RAM possible, which is not always true. Why not? If you watch my recent YouTube videos, for instance, what I did some experiments with AWS Lambda, for instance, and what not only Lambdas, all the cloud providers, what they are doing is they are coupling the amount of RAM to CPU. So if you ship, let's say, a Quarkus microservice, by the way, if you're interested, watch YouTube video from today about microprofile, AWS Lambda, and Quarkus. So what I did is I created a Quarkus app and shipped that as Lambda to the cloud. And so I could ship it with 128 megs of RAM. So it would run. This is the smallest possible amount of RAM and the cheapest solution, or possibly the cheapest solution if you would like to run Lambda. The problem is you get one full virtual CPU with 2 gig of RAM, so 1.8 gig of RAM roughly. So what it means is with 128 megs of RAM, you get a fraction of a CPU, 1/10 of a CPU. So I would say if your project is a little bit more serious, I would say in real world you would not give more, or you would not ship and production service with 1/10 of a CPU. I would say one CPU is okay. So, but then you will have to ship the entire application with 1.8 gigabyte of RAM to get, the one CPU. So what it means is, if you ship the application or the Lambdas or even serverless with more RAM, maybe, it is more cost effective because you can reduce the duration of the invocation, and there is no like a sweet spot where it executes the fastest with the least amount of costs. But usually, I see lots of optimization. And by the way, this is very good for us Java developers because it turns out that Java is incredibly fast. And if memory is not the issue, so we learned right now that actually everyone would like to have a CPU, and Java is very efficient with CPU, but not that efficient with RAM, which means Java is actually the perfect technology to run AWS Lambda, what we actually do. And it is also not said that GraalVM, for instance, is going to be cheaper to run than just Corretto 11. So why? Because in some situations, GraalVM runs 10% slower in subsequent invocation than JVM. So what can happen is that a stock OpenJDK without any optimization is going to be cheaper at the end of the month than highly optimized GraalVM for native image. Yeah, minimize the amount of communication because the communication costs money, and if you live in the cloud. So and use cheaper storage. So I see it all so instead of using relational database, sometimes projects are trying to work with hash maps again to minimize costs. So software quality, simplicity, and lean code become less expensive and less important, become less and less important, or less expensive, less important. It becomes actually more expensive to maintain and less important because everyone focuses on the costs. If not, they will kill you. Okay, now. So bandwidth, egress, NAT gateways, IP addresses, endpoints, load balancers, storage costs money. So what it means is what we talked so far was just the compute and storage. What I'm talking right now is every IP address actually costs some money, and which is not a lot, but net gateways are quite expensive. So if you have multiple subnets in the cloud, you will have to pay for it. And what would the remedy for this? Just use a serverless solution where it just runs without the NAT gateways. The problem is, of course, you cannot always do this because for larger companies, let's say you would like to have something equivalent to an intranet, you will have to run in private VPCs. So this precise billing draws management attention, and so far it always happened at the beginning of my project. So at the beginning of the cloud journey, one of the very first questions is how we can control the costs and how expensive it's going to be. And in the end of the month, the first question is, can we just ship less services or ship larger services to save money? So a big Java monolith is cheaper to run than 2 smaller monoliths. This is true. Per invocation model means, I don't know why you wrote per, just one per is enough. I'm not very good with slides, that's the problem. One Lambda function is cheaper than 2, and a single Lambda function with 2 GB RAM is more cost effective than 20 Lambdas with 128 megabyte of RAMs. So this is particularly true because, usually, right? Usually. If you have lots of I/O, it's no more true, but if you're building, if something happens in the Java code, it is the case. So serverless. So what serverless means, or what will mean for us, we will actually profile the applications or what we did in back then. We use Perform Assure or Optimize It or different profilers or the JVisual VM, for instance, or flight recorder to profile CPU and memory. And now I think what we could do, instead of looking at that, I will look now at the cost explorer and see where the costs happens, because costs are bound to CPU and memory and traffic. So it is maybe easier to profile the applications after watching the money than watching the CPUs. So serverless means no traffic, no costs. And the third point is actually the most relevant one, and this is why I believe serverless is the future, is because what business actually wants is like predictable costs. And if we have to set up something in advance, like buy machines, we never know whether we will completely use the machines or partially use the machines. But if we managed, to change the billing that we are paying actually per transaction, so now it becomes visible which business transactions are the most expensive. And this is actually what management would like to see. And this is why I believe that serverless, or at least, the business model from serverless is the future, because the first time in the history of software development, we can actually explain, management, what happens behind the scenes, non-coding management, right? So, for me, it was always the future. So I spend more time thinking about, package structure inside a microservice than shipping more microservices. I would say microservices just, a solution to a problem. If you don't have problems, don't ship microservices. This would be my advice. And now it comes the monolith or AWS Lambdas functions. They are interesting because the what you can do actually with Java very easily, you can ship entire microprofile app as a Lambda function, and now becomes interesting. So but you have to be aware that such a Lambda function is considered as being an anti-pattern. So they call it often a fat function because it does a lot. So the idea now, of the puristic AWS Lambda functions is a single responsibility principle. You have one small piece of code which does just this and nothing else. So this is the idea of Lambdas, of simple Lambdas. And what we can, this is okay, but we will have to ship for average Java applications, I don't know, a few hundreds Lambdas. So what we can do is we can actually put 10, 20, 30, 50 Java classes and ship it as a Lambda. As long as you don't have, a lot of dependencies, you can absolutely do it. So what it means, a microservice becomes a Lambda. So you might ask the question, why to do that? So if we do this, we get, the per invocation costs, and the first 1 million invocations per month are free. So this is for small applications a lot. For larger applications, nothing. So what can happen is, if you have lots of traffic, then, the Fargate or EC2 becomes more cost effective than Lambda. But I mean, for lots of applications, it is an option. And now the question is, why we can do this in Java and not, why not Python and JavaScript developers are doing this? And the reason I think is, if you remember, Microsoft invented TypeScript to have Java or C# like, type safety or modularization to implement huge systems in the cloud. So if you have Python or JavaScript, it is harder than in Java build large system. So it's not impossible, but it's harder. And I would say Java is famous to build, 2 large systems. So for us, it's not a problem, to build a huge application who no one understands. But having an application with 50 classes or 20 classes for most Java developers is tiny. They are still manageable application. And what we can do now, we can ship more with a Lambda function. With the power of Java, we get faster and save costs. And because we don't have that much Lambdas, so much Lambdas, what happens then is, if we have not, it is easier to maintain, we are more productive, and we are shipping faster. Possible future, implementing code to find and delete unused resources. This is no kidding. This is already true. I would say if you're not using infrastructure as code, if you just use the consoles, they are generating lots of code behind the scenes. It's really hard to find stuff you created. So this is no kidding. It may happen that you will have to write code which searches, you scans your environment and tries to delete unused resources. Okay, so now the last slide, Java. So we have, if we run Java, we can, the first question is GraalVM or JVM. I would start with JVM because this is not given, because of, the relation between RAM and CPU. It is not given that you will save, a lot with GraalVM. So you will have to try it out. And by the way, trying it out is the cheapest possible solution. Instead, so what I will do is ship a simple Java function and generate some load, generate some costs, and see how much does it cost. Is oft cheaper than creating a huge test environment up front. I would say Java virtual machine runs faster than JavaScript Python, and so it is more cost effective, I would say. And if it saves costs, it has bright future in the clouds. And so we have hotspot, and this also works on Lambda. So Lambdas is not like they are just forgotten after every invocation. They are frozen after every invocation, and then just reused, and the optimizations are also reused. So the very first invocation is slow and takes some time. In Java means 500 milliseconds usually, and all subsequent invocations are in the range. If this is just hello world Lambda without code, I would say 1 to 2 milliseconds. And if this is a microprofile application on Quarkus, maybe 50 milliseconds on a fraction of a CPU, right? So warm and cold starts, it isn't a problem with AWS Lambdas because they don't happen a lot. And we have the choice to use Fargate EKS, and of course with Quarkus or Micronode, both are similar. We have they are saving money for sure. So Quarkus and Micronode. Why this? What they are doing, they are eliminating reflection. They are running on less RAM, and they are optimizing the startup time, which is very good for cold starts. So with Quarkus and Micronode, you get the most optimized bytecode and runtime optimized bytecode, single class loader, no reflection, very fast startup time. So see you at upcoming workshops, and maybe I can show you both Lambdas at least. We have still a few minutes, which is incredible. So first, Lambda, and now call it DevoxxUA. And so what this is a Lambda with, looks like that. It's just a Pojo as an event listener, which listens to whatever Lambda events you or whatever events you configured this Lambda. It could be S3 Kinesis, S3 SQS, HTTP gateway, REST gateway, Dynamo DB, whatever. And this is just the plain Maven with two dependencies. So I have AWS Java Core and the events. They are not used now, but usually you would use it if you would like to deserialize the events. So I could just eliminate that. And so this was the first project, and the next one I would like to create to show you the and maybe, let's see, the other style. This is now Quarkus and microprofile Lambda. Let's say Devoxx MP for microprofile. So, and this is similar project, except it ships the entire microservice I talk about. And the microservice looks like this. So it is a JAX-RS with application scope with injection, just to see that it's actually possible. So you can use all microprofile APIs. What you should be careful with, session scoped and request scoped, because Lambda is always request scoped and the application scope is just an optimization. And what I also used here, microprofile with dependency injection. And this is just stock Quarkus. And the only difference is there's one additional extension which builds the function.zip, which allows the Lambda deployment. So this is a synchronous Lambda I talk about, and the other one is the asynchronous Lambda, which is compatible with event-driven architectures. And this is just a nice hack to package your microservice and run it cheaply as an AWS Lambda. Okay, so if I'm here, so let's go here to the folder and say build, deploy, don't ask. This will take a few minutes. And what I would like to show you so long is the references. So this is the microprofile app or microprofile APIs. And what I'm using in the example is JAX-RS. I'm using the CDI and microprofile config. Somewhere is the, I don't see the config right now. It has to be, config. Yeah, config. And I could use actually OpenAPI, whatever APIs I have, so everything would work. Some metrics make less sense because they are per lambdas, but they would still work, but are less interesting. Or health check for Lambda, right? It doesn't matter because the next time could be a different instance. Okay, so this was the Quarkus I showed you. And this is maybe interesting. So the example right now is already on the GitHub account. It's called AWS Lambda CDK Plane, documented with some screencasts, so you can watch it. So if you like to try it. And today, actually, before the show, I created a small example for Quarkus. And this is here, a fresh one. And this is what I showed you right now. So if you like, go to AWS Quarkus Lambda CDK Plane, just clone the repository and look at the code. Okay, let's see what happens here. Maybe we are lucky and it works. Where is my IDE? No, it will take too long, I think. So my machine is already hot because of these screencasts. So I think there are 3 minutes left. So you won't see the final result, but go to my YouTube channel, and this is the last. So it is actually here where I did it in 7 minutes, implemented the entire templates from scratch, and we don't have 7 minutes right now. So was fun. And thank you for attending Devoxx Ukraine, and see you at upcoming conferences, AirHacks Live, or whatever you like. Thank you.